Yeah. Okay. So it was one from a previous practice problem, and it was negative, what was it, negative 1.4? 4.2. Negative 4.2. Okay. So in a situation like that, when we're solving for a variable, we're always trying to get it by itself. And so right here, the p is multiplied by negative 1.4. So how do you get rid of multiplication? Yeah, we would divide both sides by negative 1.4, right? To get rid of that, so what you have here is you have a p. Now you just, since it's decimals, we can just pull out our calculator, and we're just dividing these. The signs we can just figure out, right? Because if I'm doing a negative divided by a negative, my answer has to come out what? Positive, and then you just plug it in your calculator. So it should come out to 3, but it's going to stay positive because it's a negative divided by a negative. Okay. And so the most common mistakes I see on ones like this are either people forget the sign and they put it negative or something, or the other thing I see kind of commonly is people reverse the division sometimes. I see that a lot. So it's always, if you're plugging in your calculator, it's always the top number first divided by the bottom number. When you plug that into your calculator. Those are the two most common things I see. All right. Any other questions from stuff you've been working on? I'll go over the stuff from Thursday right now. All right. Okay. So from the practice problems I gave you on Thursday, I had given you, we were doing ratios, unit rates, that kind of stuff. So the first ratio I had given you was 15 to 40. I was asking you to take your ratios, turn them into fractions. So 15 to 40 as a ratio, it's just the first number over the second number. But you always want to reduce your ratios because when we actually go to work with them later, you want to work with the smallest numbers that you possibly can. These are both divisible by 5. So we would reduce that. So divide 15 by 5, you get 3. 40 divided by 5 is 8. So 15 to 40 is the same as 3 to 8. That'd be that one. All right. Here, if you have decimals, so 0.42 to 1.8, that'd be 0.42 over 1.8. That's a weird way to write a fraction. Typically, fractions don't include decimals in them. So we need to move that decimal over to clear them. And you have to move it as many places as like the worst one. So the top one has 2 decimal places we need to move to get rid of the decimal because 1's not enough because that would leave 4.2. So we need to do it 2 places. But if you do it in the numerator, you have to also do it in the denominator. And so this would become 42. Downstairs, what do we have to do? We have to fill in with a 0. So be 42 over 180. Those are both divisible by what? At least a 2, right? Probably more than that, but we can go down by 2's first. 42 divided by 2 is 21. 180 divided by 2 is 90. And then those are actually both divisible by 3. So 21 divided by 3 is 7. 90 divided by 3 is 30. And then I think that's as far as you can go. 7's prime. So that'd be it. 730. It's. Yeah? All right, just let me know if you have questions. If you get into fractions, it's a little bit more of a pain, but it's not impossible. How would you handle this? What would be your first step to tackling a ratio with fractions in it? What should you do? Yeah, most of the time when you see a mixed number, it's pretty much always easiest just to go ahead and deal with impropers. So 2 times 3 is 6. 6 plus 1 is, so this becomes 7 halves. And so that's the same as 7 halves to 4 times 1 is 4 plus 3 is 7 fourths. And then you can still put it into a fraction. That's 7 halves over 7 fourths, but it creates a complex fraction. And what do we do with complex fractions? We don't actually leave them as complex fractions. We rewrite them as a division problem. So 7 halves over 7 fourths, that's the same as 7 halves divided by 7 fourths. But we really don't even divide fractions. We always do what? We multiply by the reciprocal. We flip the fraction that comes after it. So dividing by 7/4, we would rewrite as multiplication of 4/7. Then, first off, what's definitely going to happen here? Our 7s are going to cancel for sure, right? So our 7s are going to divide out because there's 7 on top and 7 on bottom. You can do this because it's multiplication. You can't do this kind of cancellation with addition or subtraction. That's something I saw that's a common mistake in addition and subtraction. You can only do this for multiplication. And then actually 4 and 2 are both divisible by 2. 4 divided by 2 is 2. 2 divided by 2 is 1. So actually all you're left with here is 2 over 1 or 2. So now the reduce ahead of time is just a shortcut I use, but it's not required. One thing, you could just multiply right there and reduce later, because like 7 times 4 is 28, 2 times 7 is 14. Well, what's 28 divided by 14? It's just, then you just reduce it down, you know. Like you might say, oh, that's divisible by 2, so that's like 14 over 7. And those are divisible by 7, so you'll still get there if you multiply straight across and then reduce. It's just whatever you're more comfortable with. So. All right. Feel okay about those? Converting ratios to fractions. All right, then then we looked at unit rates. So the next problem I had on there was a 3 ounces of chicken, and it had 141 calories. And what I wanted you to do was to calculate the unit rate calories per ounce. So rate is something that compares two things of different units, and the unit matters because the unit tells you which way to divide. So if I want you to calculate the unit rate calories per ounces, so if my unit's going to be calories per ounce, then that's calories over ounces. So your division needs to match the way the rate looks. So to do this, we need to take 141 and we're going to divide by 3. And then what does that come out to be? 47. Is it 47 even? So it's 47 calories per ounce. That would be the unit rate for the chicken. Okay? And so you pay attention because you can calculate the unit rate. You could do ounces per calorie. It'd come out to a really small number. But then if you wanted ounces per calorie, it'd flip the unit, which would also mean you need to flip your division and do it the other way. Okay. So the unit matters. So, all right. The next one was using unit rates to compare. So the idea was that you could get a 4-pack of soap for a certain price, right, $2.26. Or you could get the 6-pack, and that costs $3.42. And my question was, which one is the better deal? And so you have to decide what. I didn't tell you which way to divide the unit rate, because the thing is that the unit rate, you could do dollars per bar, or you could look at bars per dollar. Now, which one seems more intuitive? Yeah, most times when we're dealing with money, we usually put money on top, like dollars per gallon, dollars per pound, dollars per bar, stuff like that. So I would probably look at dollars per bar because then you're looking for the cheapest thing. So for the 4-pack, okay, if we're trying to go dollars per bar, then we should go $2.26, that's dollars, over 4 bars, because we're going to take 226 divide by 4, and our unit will be dollars per bar, because it's dollars over bars. And then what does that come out to be if you divide those? 0. 0 point. This is 565. That one doesn't need rounded, right? It comes out directly. So that's dollars per bar. You could do it the other way, but then you compare it differently. So Though for the 4-pack, you're paying like 56.5 cents per bar, basically. Then if you go up to the 6-pack, if we're trying to get our units dollars per bar, we need to do dollars over bars. So it's going to be 342 divided by 6. So our units will stay dollars per bar. And then what does that come out to be? That one I think does need, what's that? 0.57 even? Yeah. So these are actually pretty close in price. In fact, if you round them, they are the same. But which one is technically smaller? Which one's cheaper? This one right here, right? This one right here is of the better value. It's only slightly, but it is the better value, right? So the 4-pack is actually the better value. Because if you're going dollars per bar, you want the cheapest amount of money for a single bar. That's the better value. All right, any questions about that? Everyone feel okay about that? Not too bad. The other practice one I gave you on there was very similar. It's just dealing with dollars and ounces rather than dollars per bar. So the setup here was that there was a cereal, so you could either get 10.5 ounces of cereal for $3.47, or you could get 16.8 ounces, and that was $5.41. All right. So then to do the comparison, we're going to do the same thing. We'll look at the 10.5 ounce box. I would probably choose dollars per ounces as my unit, just because when we're dealing with money, we typically put the dollars first. And so if I'm doing dollars per ounces, what number should go on top? What number goes here? Yeah, the dollars goes on top because the dollars are on top in the unit. What number goes on bottom? The ounces, because the ounces are on the bottom in the unit. And so then what we're doing is we're doing 347 divided by 10.5, and then what does that come out to be? 0.430? 433?
There's no 4.
Oh, there's no 0. No 4 at all, sorry. I'm with you. 0.33? 0. Does it go forever? It just ends? Is that true? I don't know. I don't got my calculator. I haven't. I just let you guys figure out. 33047 ... whatever. The thing is like I usually just keep a bunch of decimal places at first because I don't know how far I'm gonna have to go to make the comparison. A lot of those decimals are probably irrelevant, but I keep them at first. So then I'll go to my 16.8 ounce container, and then so if I'm going dollars per ounces, again I need to put dollars on top because it's on top of my units, and ounces on the bottom. So we're doing 541 divided by 16.8. If you get that, what does it come out to be? 3220, whatever. Yeah. So we didn't actually need all those extra places because they're the same in the 10th spot, but as soon as you get to the 100th spot, you can tell which one's the better value. This one right here is the better value because it's slightly cheaper per ounce. Because you're going for smallest dollars per ounce if you want value. All right. Cool. Then the very last thing that we talked about in Chapter 5 was just some properties of square roots. So if you get into numbers like, for example, the square root of 64. 64 is a nice number because what is the square root of 64? You can plug in your calculator and it'll tell you. Yeah, the square root of 64 is 8. That one works out really nicely. But if you get into a number like, what's the problem with this? Yeah, it won't. Your calculator won't even do it. It'll like throw an error at you. But you can't take square roots of negative numbers, and so we would call this not a real number. So you can't take the square roots of negative numbers. Now, if the negative's outside, like the third one that I put up there, the negative root 36, is that a problem? That's not a problem. This is just saying the order of operations, square roots are like on the order of exponents or parentheses. They're pretty high up. So it's just saying take the square root of 36, which is 6, and then negate it. So you can have a negative outside the square root, no problem. If it's inside the square root, you have a problem because you can't square numbers and get negative numbers because any number squared is positive. That's the idea. Okay. If they don't have perfect square roots, it's no problem. I just told you there, just round to the nearest tenth. So you can just plug it in your calculator. 15 square root, what does it spit out? 3.9 if you round to the nearest tenth? Yeah. Okay. So it'd be about 3.9. Of course, even if they don't have a square root, like the square root of negative 30, do I even need to plug that in my calculator? I don't even need to go there because I know for a fact that I can't take the square root of a negative number. So that one's not a real number. Can't do it because the negative's under the square root. Not allowed. But the last one that I put on there, the negative square root 7/8, okay, that's not a problem. Our answer is just going to be negative. And so we would evaluate the square root of 78. What is the square root of 78? What's that? 8.8 if you round. Yeah, it'll be a bunch of decimals, but I asked you to round to the nearest tenth on those, so that'd be your answer. It'd be negative. Yeah? What do you think? Questions on any of that stuff? All right. How are we feeling about the class in general? You guys feel like the skills are okay? Are you getting enough practice in general? Okay. Okay, so then we're one of the main ways that decimals get used are when we get into problems involving percentages. And honestly, percentages are probably one of the ways that you probably interacted with decimals most, like in your actual lives, because most of us deal with percentages somewhat frequently. And so that's what Chapter 6 is all about. So Chapter 6 is all about percentages. So the term percent, okay, so cent, like cents, means 100. And so the term percent literally means per 100. And so what percentages do is they take ratios and then they scale them to a per 100 comparison. All right. So typically percentages have three forms. Okay. So percentages can be displayed in three ways. So there's the percent form, which you're all pretty familiar with. There's the fraction form, which we'll talk a little bit about today. And then there's also a decimal form of percentages. So normally, when people talk about a percentage discount or a percentage tax or a percentage tip or something, you're going to read it in percentage form. But if you actually want to calculate it, you're going to have to work with either the fraction form or the decimal form. You can't really calculate percentages without converting them either to fractions or decimals, and I'll show you why. Okay, so I'll give you an example. So first, what I want to look at is I want to look at some examples of taking percentages and turning them into fractions. Okay. So when you see a percentage, so let's say, like, for example, I gave you the percentage 18%. So I think most of us have some idea of what 18% means, right? Like as a portion of a whole. It's less than half, it's less than a quarter. All right. So if I wanted to converting percentages to fractions is actually pretty straightforward, and it's pretty straightforward because of the definition. The definition is per 100. So 18% literally means 18 per 100. And so when you're converting a percentage to a fraction, you literally just take the number and put it over 100. That's it. So 18% is the same as 18 out of 100. True? Okay, and so I can take any percentage and turn it into a fraction really easily as long as I just put it over 100. And now the only thing is that you should always reduce your fractions. And so like this one is reducible by what? They're both even, so you lose by 2. So that'd be like 9 out of 50. All right. True? Okay. If you have like, say, decimal percentages, which happens a lot. So let's say it was like 1.5%. Yeah? So 1.5%, if I want to turn it into a fraction, I just take it and put it over 100, no problem. That's 1.5 over 100. True? And, of course, we know that fractions don't typically contain decimals in them, though, so what do we have to do with that decimal? What should we... Yeah, I need to move it over to the right one spot to make it not a decimal, which means I also need to do the same thing downstairs. So there's a decimal that we don't normally write at the end of 100. If I'm going to kick it over one place value, what's my denominator going to come? It's going to become 1,000. And then, of course, reduce again. These are both divisible by 5. And so this will become 3 out of 1,000 divided by 5 is 200. All right? Nice. Then, let's see. I don't know if I really need it. Oh, you can have percentages that exceed 100%. So, like, let's say I had 110%. Well, then what would I do with that? It'd just be 110 over 100. So percentages over 100% are totally reasonable. It's just that when you put them into a fraction form, they're just going to be improper, which is okay. We deal with improper fractions. This one's divisible by 10. So if you take, what is that? That's like 11 out of 10. It'd be 11 over 10, something like that. Okay? So percentages to fractions, not too bad. Just put them over 100 and simplify them. Pretty straightforward. What about if we want to go, could we, think about this. Could you turn 9 over 50 into a decimal? Can you? Can you turn 9 over 50 into a decimal? Yeah, why not? Right? How do you do it? Like, if I were to do that, try it. What is 9? Go put 9 over 50 in your calculator. What does it spit out? 0.18, right? Well, but this started as 18%. We turned it into a fraction, but when we turn it back into a decimal, we don't get 18. What do we get? You get 0.18. But that makes sense because, see, this is 18 in the hundredths spot. Okay? But what's the relationship between a percentage and its decimal form? Yeah, it's the same number. It's just the decimal place gets moved 2 place values. Right? So 18% is 18 hundredths, which is in decimal form 18 hundredths. So when you're going between percentages and decimals, it's actually pretty straightforward. You're just moving the decimal place. So to turn a percentage into the decimal form is just two-way decimal place that way. Otherwise, if you have decimal form, it's just 2 ways that way. Right? And you can try the other ones. Like, for example, if you did this, so now try this. What's 3 divided by 200? 0.015, right? Well, what was the percentage we started with? 1.5%. In a decimal form is 0.015, and so it's just a 2 place value difference from the percentage form into the decimal form. You know, what about this? If you do 11 divided by 10, what do you get? 1.10? Yeah, 1.1, which is, yeah, or 1.10 is the same. But the reason I write it as 1.1 is because what percentage do we start at? We started at 110%. What did our decimal become? 1.10. It's just a 2 place value difference from the percentage form. All right. So the decimal form, to go from decimals, if you're going from if you're trying to go from percentage form back and forth to decimal form, right? All you have to do is you just have to move the decimal 2 places. Now, it's either going to go left or right depending on which direction you're trying to go. Right? So it just depends on whether you're trying to go from decimal to percentage. If you're going decimal percentage, it's going to go to the right. If you're going percentage to decimal, it's going to go to the left. Okay. So, but one thing to notice, right, is which form is always smaller, the decimal form or the percentage form? Is 0.18 versus 18, right? The decimal is the smaller form. So sometimes people aren't sure whether they should be moving their decimal to the left or the right. It's always two place values. Sometimes people don't know which way to go, though. And the way you know how to go is that if you're starting in a percentage form, your decimal has to be smaller. So that tells you that you need to move your decimal that way, right? Whereas if you're starting in your decimal form, I know my percentage needs to be smaller, so I move it the other way. So I'll show you a couple other examples. So you don't actually have to, if you're just worried about decimal form, you don't even have to worry about the fraction form at all. It's not really an issue. Okay. So like if I show you some example, let's say, let's convert, say, 2.8% to a decimal, right? So I have 2.8%. I know I need to move it two place values. Should I go left or right? Got to go left, right? The percentage, I know my decimal should come out smaller. If I go to the right, I'm making my number bigger. But so that means I know I need to go to the left. So if I'm moving my decimal over here, what do you have to do to fill in? Just fill in zeros, right? So 2.8% would be the same as 0.028. All right. How about if we had, say, 215%? So I'm starting with 215. Where's my decimal place in a whole number? It's at the end, right? So right now there's a decimal place sitting after the 5. We just don't write it if there's nothing beyond it. I need to move it two place values. I'm trying to go to decimal form, so I should know it should be getting smaller. So where should it go? That way, right? And so what's going to be my final answer? 2.15. So when your percentages are more than 100%, you're going to have whole numbers in your decimal form. When your percentages are less than 100%, it's all just going to be behind the decimal place. All right. That's pretty straightforward. If you want to go the other way, so let's say let's convert 0.57 to a percentage, right? So the fact that I'm given a decimal and I'm going to percentage, then I know that I need to move it two places. Now, in this case, which direction do I go? I go the other way, and so the answer is 57%. Yeah? So it's always two places. Just depends on where you're at and where you're trying to get. Okay. Let's try another one. How about this? How about convert, say, 0.005 to a percentage? So it's always two places. Which way do I go? Go to the right because my percentage form is going to be bigger. This one still doesn't make it past the 5, so what's my answer here? 0.5%. It's like a half a percent. All right? So the easiest conversions are between percentage and decimal form. You can take fractions and turn them into percentages. So like what if I wanted to convert, say, how about, say, 5/8 to a percentage? What do you think? Yeah, so the easiest way, if you got a fraction and you're trying to convert it to percentage, is just turn it into a decimal, right? So first, 5/8, we can just turn it into a decimal by taking 5 divided by 8. Okay. Well, if you do 5 divided by 8, what does it give you? 625. Now, that's the thing. If you start in fraction form and you divide it, you're going from fraction to decimal form, right? And so, which is fine, but you have to recognize that you're in decimal form. So if I want to convert that into a percentage, what do I need to do? You need to move that decimal over to place values. So going from fraction to percentage is actually like a two-step process, or at least that's the easiest way to do it. You can do it other ways, but that's the easiest way to do it, is you take your fraction and you turn it into a decimal, which is fine, and then recognize, though, that that's a decimal form, so then we can put it into a percentage form by just moving that decimal in two places. Okay? So 5/8 is the same as 62.5%. Does that seem reasonable? Like if you have 5/8 of something, does it seem like that's about the same as 62.5%? Seems about right? Because 5/8 is a little more than half. Okay, 62.5% is a little more than half. All right. So far, so good? Everybody seem reasonable? Okay. So, this is a pretty easy one, but what is 1/2 in percentage? What is 1/2 as a percentage? Half is the same as 50%, right? But if you can see the decimal approach works, because if you do 1 divided by 2, what are you going to get? 0.5, right? And then if you move that decimal over to place values, that's 50%. Okay. 50 out of 100. All right. So if you have a percentage and you want to turn it into a fraction, just put it over 100. Otherwise, you got the decimal to percentage conversion. It's just two place values. And if you're trying to go fraction into percentage, my advice is just go decimal, and then you can work with it from there. Okay. The decimal form of percentages is actually the easiest thing to work with, and that's the most common way we work with percentages is in decimal form. Okay. I'll show you why here. So, anybody have any questions about anything that's up there right now? Feels semi-reasonable. Everybody okay with that so far? Okay. Now, so then if we want to go on and it's like so then I go on and I start applying percentages. So like for example, if I might be interested, let's say you go into a store, there's like a discount, right? And it says 15% off an item, and the item costs $60 or something, right? So then the question is, well, what is 15% of $60? How do you calculate the percentage of a number? How do you calculate the percentage of a number? Well, I'm trying to find 15% of 60. I'm not trying to figure out what percentage of 60 15 is. You see the difference? Kind of, because like 15 is a percentage of 60, like you can figure that out. But I'm actually not, that's not quite what I'm looking for. I'm looking for a certain percentage of 60. Like this would be like, okay, what if you get a $60 bill and you want to leave a 15% tip? Or what if you see a $60 item and it's 15% off? What's your discount?
Divide 60 divided by 15. 0.15.
That's the key. Yeah, when you want to find a percentage of a number, you want to use the decimal form of it. Okay? Because 15% as a decimal would be 0.15. Okay? There's some other key words in this phrase, or the way I phrased this question. And we kind of talked about them before. So like, for example, is typically means what? Equals. Of usually means multiplication. 60's here. And then what? We don't know, right? So if you're trying to find a percentage of a number, you just take the percentage in decimal form and then you multiply it by the number. Okay. So what is 15% of 60? Well, then we need to go pull out our calculators and calculate 0.15 times 60. 9. Right? So if you have a $60 bill and you want to leave a 15% tip, you should be tipping $9. if you have an item that's on sale for $60, or it was $60 and it's 15% off, it's going to be $9 off. So to calculate the percentage of a number, you take the decimal form times the value. Okay. And then if you frame these problems, so this right here, this is what I call like the percent equation. There's other ways to solve percent equations, but I think this is the most straightforward way, and it's the way that's going to work as we move forward in your math classes, is if you can frame a percentage problem into a question like this, like an is-of statement or an is-of question, then the question itself tells you how to solve it, because is always means equal, of always means times, and percentages always go in decimal form, right? So when we're dealing with when we're trying to translate these things into percent equations, so is means equals, of means times, and percentages should always be are most easily worked with in their decimal form. And so this is how we're going to approach like finding percentages. Sometimes this is thought of as the part, and 60 would be thought of as like the whole, right? You're trying to find a part of a whole, and it's a certain percentage. Okay, so we'll do another one. So let's say I wanted to calculate, what is like, for example, our tax rates are 8.6%, right? Is that true? In Benton and Franklin counties, I think, right? So you go into the store, someone gives you a price quote on something. So, like like I told you, like my HVAC system broke, so now I got these like quotes for like really expensive. I got to replace my air conditioner on my house, right? So they give me a quote, but it's pre-tax, right? So then I need to figure out what the tax is, so I can figure out what the final problem is. So like, let's say, what is 8.6% of like $7,600, right? Because they might come back and say, well, I'll do it for $7,600, but then I'm going to have to pay more than that, obviously, because I'm going to have to pay tax on it, right? So here, tax rate's 8.6%. All right. So now, if you recognize it, you can know that you're just multiplying the percentage times the 7,600. But we can translate that into a percent equation, because anywhere you see a what, that's where you put a variable. I always just use x because that's the most common variable. What we don't know, is means equals. 8.6%, we need to convert it into its decimal form. So what would be the decimal form of 8.6%? 0.086. Of means times 7,600 is the value, right? And so then you just take 0.086 and then you go $7,600. Okay, so what does that come out to be? 653.6. And if we're talking about dollars here, right? So that tells me that it's $7,600, but if you're going to have to pay tax on that, you're going to have to turn around and spend another $653. So actually the cost of this thing goes up over $8,000, right? After tax. Same thing with if you're buying something at a store, right? You see an item, you're trying to figure out the after-tax costs. You can calculate the tax you're going to have to pay by just taking 0.086 times the price, and that'll always give you the tax rate. At least in like stores. Groceries are different. I don't think we pay tax on groceries, do we? In Washington? No, we don't. Okay. All right. Does that make sense? Everybody, does that seem reasonable? So calculating a percentage number, pretty straightforward. It's just the percentage times the number, but you want to always make sure you're dealing in decimal form with percentages. Now, that I might ask a different question. It could be that maybe the discount itself, like maybe I'm going to tell you, okay, there's an item that's $60, and I'm going to give you $15 off. Well, what percentage discount am I giving you? So I don't tell you the percentage, I give you the actual count. So like in that case, I could ask the question like, okay, well then 15, maybe I don't know Like I could ask that question differently, like 15 is what percent of 60? So how would you solve that problem?
15 times X.
So that's the thing. That the percent equation, it makes things nice because the percent equation helps you decide whether you should multiply or divide or what do you divide by what. So if I translate this, 15 should be equal, what percent we don't know, of means times 60, right? So then how do I solve this equation? Well, we know how to solve equations. The equation now tells us what we should do. What should we do? We should divide by 60. Yeah. So to solve this equation, we need to figure out, well, what is 15 divided by 60? All right, perfect. So then what you get is you plug it in your calculator, though, and you get 0.25. Now, is that the answer? Kind of, except for, is that the percentage? It's not the percentage. This is why it's important to remember that when you do fractions, like if you do the division, it spits it out in decimal form. So it's not 0.25%, it's actually what? Yeah, you need to correct and turn it back into a percentage. Okay. So you always put the percent into decimal form when you're working with it, and vice versa. When you actually work with the equation, if the equation spits out a percentage, it's going to come out in decimal form, and you need to correct for that. Okay? Does that make sense? Okay. And then you could also, let's see, what's the other way you could do this? This could be like, I could say, how about, let me write that another way. Let's say my question was, say 80% of what number is 50, right? This is an even different question because I'm saying, there's some percentage of a number. 80% of what number is 50? So 50 is like a percentage of a number, right? Is the number I'm trying to find going to be bigger or smaller? So 80% of what number is 50? Is the missing number here bigger or smaller than 50? So 80% of 50 would be smaller than 50. But that would be a different question. That would be if it were phrased 80% of 50 is what number? Right? Like if I'm actually doing 80% of a number, 80% of 50, that would come out smaller, but that's not quite the way it's phrased, right? This is saying 80% of what number? So there's a missing number, and 50 is 80% of it. Okay. So that's why these percentage problems can be really tough, so that's why falling back on the percent equation approach is always a decent idea, because I don't really need to hash out, whether it's going to be bigger or smaller ahead of time. I can just immediately translate it into an equation. So like 80%, what would that be in decimal form? If I turn that to decimal, it would be what? Yeah, move it over 2 places. So 0.8 of what number we don't know, of means times, right? What number we don't know, is means equal 50. Right? So then to solve this, what are we going to do? We would end up dividing, and we're going to divide by the decimal. So our answer is going to be 50 divided by 0.8. Right? And then what does that give you? 62.5. Okay. So the percentage problems can get really complicated, but if you remember like the is of, percentages decimals, then you can set up the equation and you don't have to try to hash it out in your mind, try to figure out, okay, am I multiplying, am I dividing? If I'm dividing, what number gets divided by what? You don't have to worry about that. You just translate it into the equation, and the equation tells you what to do. You know, the equation tells you how to solve it just by setting it up. Oh, okay, I got to divide by 0.8 here. You know, whereas like if you look at the first one, what is 15% of 60? Oh, all I got to do is multiply those two numbers together. No problem. Okay? So I have some of these is of percent equations. First, I just want you to practice solving them. Then what we'll do tomorrow and moving in through chapter 6 is we'll start to look at more applications of percentages. But first, we just want to get comfortable working with them. I don't think you'll have time to finish. Well, we only have 10 minutes. So I don't think I have time to finish this. I'll go over these solutions tomorrow in class. But give them a try tonight if you can for practice. And don't forget, if you haven't taken that last chapter 5 quiz, make sure that you get it done tonight because it's due today. That's the end of the decimal stuff.